Algebra 2 Cram, New York State Algebra 2 Regents, Common Core, Basic Graphs of Trigonometric Functions, Domain of the cotangent of x, Concept number 7. The odds of someone doing exactly what you tell them to do is pretty slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. So inbox me at memedicine@gmail.com and be sure to spread the word. If this isn't the subject you're looking for, still inbox me at memedicine@gmail.com and inquire about purchasing personalized packages. All right, let's delve into the domain of the cotangent of x. Basic graphs of trigonometric functions, domain of the cotangent of x, an angle x, that is. And before we get into the actual concept, let's reorient ourselves and recall to memory what the cotangent is exactly. So here we have our x, y, Cartesian coordinate plane, with the vertex of an angle at 0 at the origin, and the initial side ray of the angle going to the extent of its x-coordinate, and the terminal side ray terminating in quadrant 1 going to the extent of the y-coordinate here. Okay, and we see that this is an acute angle because it's formed between 0 degrees and 90 degrees. And we're calling this angle theta rather than calling it x because we're going to use x here to demonstrate the x-coordinate. So we don't want to double up on variables. It would get confusing if you call the x-coordinate x and the angle x as well. At least here, okay, not over here for what I'm going to show you. So yeah, variables, remember, are interchangeable, but we're just going to use standard variables. And theta is like the alternative variable for an angle when you can't use x, okay? So this angle, all its characteristics also make it a reference angle. Let's try to, reference would be like a sub REF, okay? Just pretend that's like sub REF written neatly, although it's not. And the definition of a reference angle is a positive acute angle whose initial side is on the x-axis and terminal side ends in a quadrant. So let's say this acute angle were 40 degrees in quadrant 1. And the reason, if you were to calculate the sine, cosine, secant, whatever trigonometric value of 40 degrees in your graphing calculator or scientific calculator, it's always going to calculate the value for the reference angle. But let's say you did a horizontal flip and this 40 degrees was over here. Well, you would have to recall that in quadrant 2, the convention, let's say you get the value for 40 degrees in your calculator, you would subtract that 40 degrees from 180 degrees and you would be calculating the value of 140 degrees. And you must take note whether or not your value is going to be negative or positive, okay? Let me show you what I'm talking about. So the cotangent of theta is going to be the x-coordinate divided by the y-coordinate. And we know that the tangent of theta, tan, is equal to the, sorry for my scribble, the y-coordinate divided by the x-coordinate. So these this is a cofunction of theta. And what that essentially means is if you were to multiply them, you would get 1 because they're the fractional reciprocals of each other. Even if they were expressed as decimals and you multiply them by each other, you would get 1, okay? So now we're going to see why over here the cotangent of theta in quadrant 1 is going to be positive, but in quadrant 2 it's going to be negative. And that's because the x values in quadrant 2 are all negative, okay? There's negative x values. So whenever you get a value for your reference angle in your calculator, you're going to have to determine what the angle is depending on your quadrant of interest. And then you're going to have to determine the sign depending on whether or not you're using a value that has a negative x region or a negative y region, okay? All right, that's that. Okay, so yeah, this is the cofunction of the tangent of theta. I think I said that already. Oh, and whenever you're dealing with like sine or cosine, the hypotenuse is always the denominator, or whenever the hypotenuse is factored in to the trigonometric function, the hypotenuse value itself is always going to be positive because it's a measurement of magnitude and it's not a coordinate, okay? But depending on where you are in the Cartesian coordinate plane, your values can be negative or positive. So let's say you had the reference angle 40 degrees over here. Let's say you did like a diagonal flip about the origin. And so what you would have to do is add 180 degrees to that 40-degree angle to get the actual angle that you're looking at, and it would be 220 degrees. And let's say you did a vertical flip, I think this is called, over here into quadrant 4, and you're still dealing with a reference angle of 40 degrees, well, you would have to subtract it from 360, and I think you would get an angle of about 320 degrees, okay? So yeah, be careful with reference angles, and the main thing I want you to take away is that this is what the cotangent of theta is. Now, if this triangle was not a right triangle, because you can clearly see here that it is, you can still calculate trigonometric values and even its cotangent. It's just going to be the value of the adjacent side with regard to theta divided by the opposite side, okay? So I just wanted to orient you and get you to recall a few things. It's a long intro. Now, what is the domain of the function y is equivalent to the cotangent of x? I want you to draw out a graph. So definitely press pause now if you need to. And yeah, I'll give you a moment to think. All right, so hopefully by now you were able to draw out your graph and express the domain of the function y is equivalent to the cotangent of x. And if not, that's totally fine. But what you need to understand is that the domain of a function is the set of all possible independent variables. These are the variables on the x-axis, usually called the x-values. And here we see the graph of our function y is equivalent to the cotangent of x. Some people get thrown off because when you draw out this graph on the x-axis, you have to have radian pi measurements, okay? So you usually go in increments of pi over 2. So pi over 2, pi, 3 pi over 2, and so forth. And the same in the negative x or negative infinity direction, okay? All right, so after a quick visual inspection of this graph, you're going to notice that the domain of the function y is equivalent to the cotangent of x is all real numbers except multiples of pi, okay? Not pi over 2, just whole number multiples of pi. And why is that? Well, it's because of what I showed you initially, okay? So if the cotangent of theta is going to be x over y, we know that when for whole values of pi, the y or the sine value is going to usually be 0, okay? Well, this is pi over 290 degrees, but when we get over here to 180 degrees, which is 1 pi, there's no y direction, so it's 0. Same when you get over to 360, it's 0. And whenever you have a 0 in the denominator, your fraction is going to be undefined and create a vertical asymptote. So here we see approaching 2 pi, approaching pi, but never actually touching. So it kind of just goes on forever, traveling in negative infinity y direction, positive infinity y direction. And also, this is a big deal, okay? Just in case you forgot what a real number is, a real number represents a value along the number line or the horizontal axis or the x-axis in both the positive and negative infinity directions. And real numbers, they include rational and irrational numbers. A rational number can be written as a over b as a fraction where the a value terminates, b is not equal to 0, but it can be equivalent to 1. Hence, this is a rational number. Counting numbers like 0. Yeah, rational number always also include integers or counting numbers like 0, -1, 2, okay? And real numbers, they also include irrational numbers that cannot be written as a over b, where b is not equal to 0, but can be equivalent to 1, because they don't when you try to express the numerator as a decimal, it never terminates or it never repeats, such as the square root of 2. Okay, this is not a rational number, rather, it's irrational, because if you were to express this, like radical 2 over 1, even you would feel a little uncomfortable. It's not the same as 2 over 1. And that's because when you try to break down 2, like you get this intuition that something isn't right. When you try to evaluate the square root of 2 over 1, you get 1 point, I don't know, it's like 4, 1. Try to memorize this. 4, 1, 4, 2, 1, 3, 5, 6. Dot, 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 like it goes on and on forever. Same thing with the number pi, not radian pi, okay? So yeah, that's just an intro on real numbers, irrational, integers, irrational, the Cartesian coordinate system, where the concept of the cotangent comes from, quadrants, all that good stuff. All right, thanks for your time. I know this is supposed to be a cram, but hey, it's an extended cram. You get the drift. So definitely order this complete session so that you can get the most. And like I said before, I guarantee you I'll make you into an Algebra 2 master, and I'll smash your current paradigms that make you think that you can't be like a mathematical genius, because you are, else you wouldn't be here with me, okay? All right.